Today we are going to talk about graphing square root functions. So it says using a graphing calculator, I'm going to use Desmos, graph the function f of x equals the square root of x. Identify three ordered pairs that are solutions of the function. So f of x equals the square root of x is a parent function that we're going to be talking about today. When it says identify three ordered pairs that are solutions of the function, that just means identify three ordered pairs that fall on that graph. So if I open up Desmos, you can see that I have right now showing the square root of x. It has a clear starting point, and then it continues on to the right forever. And if I scroll over here, you can see it just keeps going to the right forever. So when we go ahead and graph these, they're asking for 3 points. I'm just going to pick the first 3 points that are not decimals. So I'm going to pick 0, 0, I'm going to pick 1, 1, and 4, 2. So I have 0, 0, 1, 1, and 4, 2. Now these numbers make sense because if you do the square root of 0, you get 0, the square root of 1 is 1, and the square root of 4 is 2. You can choose whatever numbers you want here. These are just the first 3 that are integers, and so it will make my life easier when I go and graph them. And so this graph starts at the origin and then it goes to the right forever. So notice how I didn't put an arrow over here. It's because it starts here and then it continues to the right forever. So we do put an arrow on the right side, but this is our starting point, so that does not get an arrow. Now down here it says to identify the domain and range using interval notation. Now, if you forgot about interval notation, remember that you use a bracket, which are these square grouping symbols here, for solid lines and for closed circles. And then we'll use a parenthesis, so these curved grouping symbols for dashed lines, open circles, or positive and negative infinity. So you'll recall that your domain are your x values from left to right. My furthest point to the left is this point right here. This is where x is 0. My graph is going to the right forever, so that's going to positive infinity. So my domain from left to right is from 0 to infinity. 0 will get a bracket because it's a closed circle. Infinity always gets a parenthesis. Our range are our y values from the bottom of our graph to the top of our graph. The lowest point on my graph is this point right here. This is where y is 0. My graph is going up forever, so that's going to infinity. So my range from the bottom of my graph to the top of my graph is from 0 to infinity. 0 will get a bracket because it's a closed circle. Infinity always gets a parenthesis. So let's go ahead and see if we can identify any transformations here. It says graph the following square root functions using a graphing calculator. Identify any transformations from the parent function f of x equals the square root of x. So on example 1, we have y equals the square root of x plus 4. So if we go back over to Desmos, if I graph the square root of x plus 4, we can see from the red line to the blue line that this has moved everything up 4 units. So if I come back over here, this transformation is up 4 units. And so those ordered pairs were 0, 4, 1, 5, and 4, 6. And again, I'm just using the first 3 that are integers. And you can get that just by looking at your graph on Desmos. Excuse me. On example 2, we have g of x equals the square root of x minus 3. So if I go ahead and go back to Desmos, I'll hide this one, and let's show x minus 3. And so here, x minus 3, if this is our original parent function, we've now shifted down 3 units. And so if we go back over to our notes, this is a transformation of down 3 units. And those first 3 points were 0, negative 3, 1, -2, and 4, -1. And so this one looks like this. Now, if we look at example 3, for example 3, we have the square root of x minus 1 all underneath the square root symbol. This is the square root of x. That's our parent function. We've now shifted it to the right 1 unit. And so if we look back over here, this has been transformed by translating to the right 2 units. And those first 3 ordered pairs, let's see, I have 1, 0, that looks like 2, 1, and 5, 2. So 1, 0, 2, 1, and 5, 2. And so this function looks like this. So that was when we subtracted 1 underneath our square root symbol. On example 4, we're going to do x plus 2. So let's see how that transforms things. So if I have x plus 2 here, well, this is my original, and this is my new function, and it looks like we have shifted to the left 2 units. And so when we went to the left 2 units, let's see, my points are going to be -2, 0, -1, 0, and then I'll use this one here, which is 2, 2. On this one, I said right 2 units. It did not go right 2 units. It went right 1 unit. Sorry about that. So this is left 2 units. And again, those ordered pairs were -2, 0, -1, 1, and +2, 2. And so this one looks like this. Let's go ahead and look at example 5. So on example 5, now we have this 2 out in front. So let's see how that changes things. And so when we have that 2 out in front, we've gone from this, our original function, this one right here, our original function, to this new function. This is a vertical stretch by 2. And by looking at the graphs, you can see how it's pulling it up. And so here my ordered pairs, I'm going to use are 0, 0, 1, 2, and 4, 4. So 0, 0, 1, 2, and 4, 4. And so this one looks like this. And again, this was a vertical stretch by 2. So what's going to happen if our A value is 1/2? Well, let's see. If A is 1/2, well, this has been a vertical compression, also known as a vertical shrink. And so when we have that, let's see, our new function is going to be at 0, 0. This is 1.5, 1.5. So that's going to be an easy one to graph there. And then I'm also going to graph the 0.41. If you wanted to keep going, I think, let's see, the next one that's going to work would be 9, but that's still going to be a decimal. So then after 9 is 16. So 16 would work as well. But I'm going to choose 0, 1, and 4. If you're ever not sure, remember that you can hit the settings gear and then click on table. And so here I could change this one to a 4. And you can see that those are the 3 points that I'm going to graph. These 2 up here are listed as undefined because the graph hasn't started at those points yet. So again, these 3 points, 0, 0, 1.5, and 4, 1 are the 4 that I'm going to, or the 3 that I'm going to use there. Just because I know that those 3 are easy to graph and will be on my graph. And so this one will be like this. And again, this is known as a vertical compression or a vertical shrink, however you want to call it, by a factor of 1/2. Now, on example 7, here we have a negative out in front. let's see how that negative changes things. Whoops. Let's go here. And so if I turn that one on, let's see. So now we have a reflection across the x-axis. And so everything has just reflected across that axis. So I'll have 0, 0, 1, negative 1, and 4, negative 2. Now if we look at example 8 is a little bit different. Here we have a number in front of our coefficient of x inside the square root symbol. And so we haven't really talked about a situation like this before, so let's see what happens. If we put the negative inside, we get a reflection across our y-axis. So this is a reflection across the y-axis. And here those points would be negative 4, 2, negative 1, 1, and 0, 0. And so that one would look like this. So if we scroll down here, you'll see that we have all of the transformations that we've been talking about with the other functions that we have learned. We still have our a, h, and k values. A will tell you if you have a stretch, a shrink, or a reflection across the x-axis. X minus h will tell you if you go left or right. K will tell you if you go up or down. But now we have this new value of b. So the rules for b are if the absolute value of b is greater than 1, then you will have a horizontal compression, or also known as a horizontal shrink. If the absolute value of b is in between 0 and 1, then you will have a horizontal stretch. And if b is less than 0, so if b is negative, then you will have a reflection across your y-axis. Now, one thing that I do want to point out to you is in this formula, you'll notice how x minus h is inside of parentheses here. Whenever you have a b value, you'll want to make sure that x minus h is inside of parentheses because that will just help you identify the transformations better. So if you get an equation like this and b is not, or x minus h is not in parentheses, go ahead and factor out that b. It's like a GCF there to get x minus h inside parentheses. That way you can clearly see what the transformations will be left and right. With that being said, let's go ahead and look at example 9. So on example 9, we have f of x equals the square root of x minus 1 plus 3. So the first thing that I notice is that I have x minus 1 underneath my square root symbol. That tells me that this graph is going to the right 1 unit. I can also see that I have plus 3 on the end here. So that tells me that this graph has been translated up 3 units. Now, one other thing I do want to mention about this formula here is that HK will tell you your starting point. And so whenever you find HK, just like how we did with quadratics, you will change the sign of H because of that negative inside there. It kind of changes things for you. So change sign of H, and you're going to keep the K value, you keep the sign of K. And that will always tell you your starting point. So on example 9, I can find my starting point by finding my HK value. So here I have x minus 1. So if I change the sign of H, I'll have positive 1. And if I keep the sign of K, I'll have positive 3. So when I go ahead to find my 3 points to graph, I know that starting point will be 1, 3. So let's go ahead and open up Desmos. And if I graph this one, We can clearly see that from our parent function to our new function, that starting point has shifted right 1 and up 3 units. That starting point is the HK value that we found of 1, 3. I'm also going to use the point 2, 4. And I'll also use this point right here of 5, 5. So we have 2, 4, and 5, 5. And so this is what that graph looks like. Now they are also asking for the domain and the range. Remember that your domain are your x values from left to right. My furthest point to the left is this point right here. This is where my x value is 1. My graph is going to the right forever, so that's going to infinity. So my domain from left to right is from 1 to infinity. Now this isn't written in interval notation. In our directions, they didn't specify if they wanted it in interval notation or inequality notation. So if you wanted to write this as an inequality, you could say, okay, these are my x values. I'm starting at 1 and I'm going to the right forever. So I could also write this as x is greater than or equal to 1. Our range are our y values from the bottom of our graph to the top of your graph. The bottom of my graph is this point right here. This is where f of x is 3. My graph is going up forever, so that's going to infinity. So my range from the bottom of my graph to the top of my graph is from 3 to infinity. Another way that I could say this is that I'm starting at 3 and then I'm going up forever. So we could say that y, or in this case f of x, is greater than or equal to 3. Your x-intercept is where your graph crosses your x-axis. This curve does not currently cross my x-axis, nor will it ever, and so I do not have an x-intercept here. Your y-intercept is where your graph crosses your y-axis. Again, it's not currently crossing my y-axis, nor will it ever, so I do not have a y-intercept for this one. On example 10, here I have the square root of negative x minus 2. Now, the first thing I notice is that I do have a b value and that x minus h is not in parentheses. So the first thing that I'm going to do is I'm going to factor this out. It looks like my b value is negative 1, so I'm going to go ahead and factor that out. So I'll have y equals the square root of negative. If I factor out a negative 1 out of negative x, I'll have x left over. And if I factor out a negative 1 out of negative 2, I'll have positive 2 left over. Now remember, you can just multiply it back out to get this back. Negative times x is negative x. Negative times 2 is negative 2. So we haven't changed the equation at all. We've just written it so that we can more clearly see our transformations. So now I can see that my b value is in fact negative 1. So that tells me that I have a reflection across the y-axis. Inside of my parentheses, my x minus h is x plus 2. So that tells me that I'm going to the left 2 units. My h and k values, let's see. So my starting point of hk. So if I change the sign of h, I'll have negative 2. And if I keep the sign of k, well, I don't have a k value, so that's going to be 0. So my starting point is going to be the point 2, 0. Sorry, negative 2, 0. So let's go ahead and look at this graph. And you can see that it has reflected over the y-axis, that our starting point is negative 2, 0, and we have shifted to the left 2 units. So I'm going to use the point negative 2, 0, negative 3, 1, And let's zoom in here. Let's see. -6, +2. It's gonna drive me nuts if I don't put this in numerical order. So let me do that. So I have -2, 2, negative, what was it? 3, 1, and -2, 0. So we have -2, 0, -3, 1, 4, 5, 6, 1, 2. Here is this graph. Your domain are your x values from left to right. My graph is going to the left forever. That's going to negative infinity. The furthest point to the right is this point right here. This is where x is -2. So from left to right, my domain is from negative infinity to -2. As an inequality, everything is going to the left from -2 from our starting point. So everything is smaller than -2. So this would be x is less than or equal to -2. My range are my y values from the bottom of my graph to the top of my graph. The bottom of my graph is this point right here. This is where y is 0. My graph is going up forever, so that's going to infinity. So my range is from 0 to infinity. Or we could say that y is greater than or equal to 0. Your x-intercept is where your curve crosses your x-axis. Well, that is happening right here at the point -2, 0. Your y-intercept is where your curve crosses your y-axis. My curve does not currently touch my y-axis, nor will it ever, and so I do not have a y-intercept here. Let's go ahead and look at our last example, example 11. So on example 11, the first thing that I notice is that I have a negative for my a value, and so that tells me I'm going to have a reflection across my x-axis. I also see that my a value includes a 2, so that tells me that there has been a vertical stretch by 2. And that we have shifted up 6 units because our k value is 6. So let's go ahead and look at Desmos and see what this one gives me. And we can see here that we have reflected across our x-axis. We do have a stretch of 2, and we have moved up 6 units. So I'm going to use a point 0, 6, 1, 4, and 4, 2. So we have 0, 6, 1, 4, and 4, 2. Again, you could have also have found your HK value by looking at your graph, seeing that you don't have an H value at 0 and your K value is 6. So you could do that either way. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 1, 2. So here is that curve. Your domain are your x values from left to right. My furthest point to the left is this point right here. This is where x is 0. My graph is going to the right forever, so that's going to infinity. So my domain from left to right is from 0 to infinity, or we could say x is greater than or equal to 0. My range is my y values from the bottom of my graph to the top of my graph. The bottom of my graph, well, that's going down forever, and so that's going to negative infinity. The top of my graph is this point right here, and that's where y is 6. So my range from the bottom of my graph to the top of my graph is from negative infinity to 6. And remember, this graph is just keeps going down forever. And so that's why it's going to negative infinity. We could also say that negative or positive 6 is the top of our graph and everything is less than that. So because we're dealing with g of x here, this would be g of x is less than or equal to 6. Your x-intercept is where your curve crosses your x-axis. And if we look at Desmos, I can see that we do have an x-intercept here at 9, 0. Even though I'm not seeing it on my graph, I know that this is going to keep going down forever. So eventually it will cross, and it does cross at the point 9, 0. Your y-intercept is where your curve crosses your y-axis. That is happening right here at the point 0, 6.